Okay, this is problem 48 in your book, or in your packet rather. You got three vertices, A, B, and C, and you want to find the median, equations of median, perpendicular bisector, and the altitude to side AB. Okay, so first we'll do median. Median uses basically the opposite vertex of AB and then the midpoint of AB. So those are my 2 points. The midpoint of AB is pretty easily. If 5 plus 6 is 1, divided by 2, midpoint formula, 4 plus 4 plus 8 divided by 2 is going to be 4. So 1/2 4 is the midpoint. So my points I can use are C, so I connect these, that's my median, are C, which is 7, 2, and then the midpoint, which is 1/2 4. So the slope is the slope between these 2 points. Okay, so I got to do 4 minus 2, or y2 minus y1 over x2 minus x1. I end up with 2 over negative 6.5. You plug that into your calculator, you should get negative 4/13 as your slope, because you don't want decimals in your fraction. You want it to look as nice as possible. So there you go. So there's my slope. I'm going to use this point simply because it looks nicer than this one, and it's got whole numbers. So I'm going to go now and find the equation. So y equals mx plus b. Y is 4. M was negative 4/13. X is 7. Oops, I mean, y is actually going to be 2. You guys catch that mistake? So y was 2, sorry. M is 4/13. X is 7. And I'm going to find b. So when I do this, I figure out my calculator, you should get negative 4/13 times 7. It gives you negative 28/13. 2 is like 26/13, so 26/13, 28/13. You end up with 54/13, which isn't pretty, but that's your answer. So my equation for the median is y equals negative 4/13 x plus 54/13. So just to double check that I did that right, I got negative 28/13, so 2 plus 28/13. Let's give me 54/13. Okay, now perpendicular bisector. Well, now perpendicular bisector isn't exactly like the median because it's not coming from the vertex, right? The perpendicular bisector again goes through the midpoint. So now my point is definitely the one I just found, 1/2 4. So a lot of your legwork has already been done. I just need to find the slope. Well, the slope of this line is actually kind of easy, because if you look at the slope, it's going to be the opposite reciprocal of AB, and the slope of AB is going to be 0. And if you wanted to confirm that, you could just go ahead and do 4 minus 4 all over 6 minus negative 5. See, it's going to be 0 over 11. So the opposite reciprocal of a 0 slope is undefined. So basically what you find out is this is a straight vertical line. This perpendicular bisector is straight vertical through the point 1/2 4. Well, we learned that a vertical line has the equation x equals, in this case it's just x equals 1/2. The altitude is going to have a similar equation, yet it's going to have the same slope. Okay, slope already I know is undefined, but the point is different. Okay, the point is not the midpoint. Okay, as you saw a perpendicular bisector, use a different color here. As you saw a perpendicular bisector, this is the midpoint of AB. In altitudes, the point I use is going to be the opposite vertex to AB. So the point is going to be C, which we use to find the median actually, and that's 7, 2. My slope is still going to be the same because it's still perpendicular to AB. It's going to be the same as the last one, perpendicular bisectors. It's going to have a slope of undefined. So basically what you got is a straight vertical line. If we could draw this, it's going to actually land outside, but it's going to be a straight vertical line through the point 7, 2. Well, straight vertical through that point is going to be x equals 7. So that's how you would find the equation of the median, right here. The equation of the perpendicular bisector, right here. And then again, the equation of the altitude, right there. So you know that the altitude and the perpendicular bisector both have the same slope. They're both perpendicular to the line, yet perpendicular bisector goes through the midpoint, altitude goes through the vertex, the opposite vertex. Okay, so that's a good example of the difference between these three types of lines. Problem 53 is the next one. Find the volume and surface area of the wedge of cheese that was cut from a cylindrical block. So the radius is 5 and the height is 15. So this is what I got. Radius 5, height 15. So first thing you're going to do is find the volume. And basically what you have here is you have a cylinder in which you got this little wedge cut out of it. So it's like fractions. Okay, what fraction of the entire cylinder is that wedge? And the fraction of the entire cylinder is given by that 20 degrees. So the volume is actually going to be basically 23/60ths of the volume of the whole cylinder. Okay? So 23/60ths is actually breaks down into 1/18. So whatever the volume of the entire cylinder is with radius 5 and height 15, I know the volume of my little wedge is going to be 1/18 of that. And it kind of makes sense. You could figure out the area of this part as 1/18 the circle, and then times that by 15. It's going to be the same exact thing. So basically what I get is 1/18 the volume of a cylinder is pi r squared times the height. So it's 1/18 pi times the radius 5 squared times the height 15. So basically when you multiply all that out, you get 5 squared times 15 is going to be 25 times 15 divided by 18 or times 1/18. And I should get 125 pi over 6. We're talking about volume. So this is units cubed. All right, so that's volume. Surface area, on the other hand, is a little bit more difficult. So let me draw that over here so we can get as much room as possible. Okay, the surface area, you could think of it in a few ways. I'm just going to show you the way that we did it in class. In the surface area, basically, what I have for surface area is I got 2 sectors. So I got area of 2 sectors. I have the curvy side here. So you got plus the area of the curved piece. I don't know what you would like to call it, whatever you want to call it. And then finally plus the area of the 2 rectangles that are created. If you're like, what are you talking about, 2 rectangles? Well, those are like the sides. If you can imagine this wedge, there's one here, and there's actually one on the back side, if you could picture that. So I kind of just colored that whole thing in, but to kind of maybe clarify this, you got the 2 sectors, the curved side, and then you got this rectangle, and then you got the back rectangle. So you got 2 rectangles there. So what I could do is just find the area of 2 sectors. So the area of one of the sectors we just figured out is 1/18 the area of one circle. So it's 1/18 pi 5 squared. But you got 2 of them, so that's why I multiplied by 2. The area of the curved piece is going to be 1/18 times the lateral area of the whole cylinder. Okay? And then the area of the 2 rectangles, well, that's going to be 2 times the rectangles, which are 5 by 15. Height 15, radius 5. The radius is the length, and the 15 is the height, whatever you want to call it. The length times width, base times height, area of a rectangle. So it's going to be 15 times 5 is 75. So we'll just show that little intermediate step there. Okay, so what I end up with here is 1/9 times pi times 25. The lateral area of a cylinder is 2 pi r, while r is 5, times the height. And these are all formulas that you could put on your little formula sheets, your little note card. And then this is going to be 2 times 75. So it's just a matter of now just putting it all together. So I got 25 pi over 9 plus 2 times 5 times 15 divided by 18. So that gives me 25 pi over 3 plus 150. Well, I can combine these if I just make their denominators the same. This is going to be 25 pi over 9 still. I'm going to make this denominator 9, but then I got to multiply that by 3, so this makes this 75 pi plus 150. So this gives me 100 pi over 9 plus 150. Surface area, so that's units squared. So again, the volume, 125 pi over 6. Surface area 100 pi over 9 plus 150. I hope this helped you with these two questions.